Hello friends, my name is Abhishek Srivastava. Today we are going to do the topic of dimensions, and we are going to do the questions for it of subject physics of class 11. So we are proceeding with the questions. So find the formula E equal to 2 pi root L by G by dimensional analysis. So this is our question. So we have to find it. So with the help of dimensions. So we are proceeding with the question. So this is the time period which is directly proportional to A L raised to power A G raised to power B. So now we are writing it in terms of dimensions. M, this will be T, so it will become M raised to power 0, L raised to power 0, T raised to power 1 is equal to K, and it will become L raised to power A, and it will become L T raised to power minus 2 B. So this is our equation. So now comparing the powers of L and T. So 0 is on both sides. 0 is equal to A plus B. This is our first equation. The second equation is 1 is equal to minus 2B. So B is equal to minus 1 by 2. This is the value of B. So A is equal to minus of B is equal to minus of minus half. So A is equal to 1 by 2. This is our equation of A. So our formula, substituting this value, T is equal to K, and it will become L raised to power half G raised to power minus half, and K is equal to 2 pi 1 upon 2 pi. So T becomes 1 upon 2 pi, it is 2 pi. So it is 2 pi root of L by G. So this is our equation. So I think you all might have understood this question. So we are going to understand this question once more. We have to derive the formula T is equal to 2 pi root L by G with the help of dimensional analysis. So T is directly proportional to L raised to power A, G raised to power B. Writing it in terms of dimensions, M raised to power 0, L raised to power 0, T raised to power 1 is equal to K is a constant, L raised to power A, and the dimensions of G, L T raised to power minus 2 whole raised to power B. So equating the powers, comparing the powers of L and T on both sides. So 0 is equal to A plus B. This is our first equation. Second equation, 1 is equal to minus 2B. So B is equal to minus half. So A is equal to minus B. So it becomes minus of minus B. So A is equal to half. So A comes out to be half and B comes out to be minus half. So substituting this value here, T is equal to 2 pi and L raised to power half, G raised to power minus half. k constant is 2 pi. So the formula becomes t is equal to 2 pi root L by G. So this is our formula. Now we are proceeding to the next question. Derive centripetal force F is equal to mv square by r by dimension analysis. So we are proceeding with the question. F is directly proportional to m raised to power a, v raised to power b, r raised to power c. This is our first equation. So here we can write in force m L T raised to power minus 2 and is equal to k, and it will be m raised to power a, velocity Lt raised to power minus 1 whole raised to power b, and L raised to power c. Radius is the length, so its dimension is of length. Velocity is Lt raised to power minus 1 and mass is m. So now comparing the powers of m, L and t on both sides. So it is 1 is equal to a. So the value of the constant a is 1. Similarly, comparing the powers of L, so 1 is equal to b plus c. This is our second equation. And minus 2 of t, minus 2 is equal to minus b. So b is equal to 2. Substituting the value of b here, so it becomes 1 is equal to 2 plus c. So c is equal to 1 minus 2 is equal to minus 1. So substituting these values in the first equation, f is equal to k, and it will be m raised to power 1. V is the velocity, that is raised to power 2, and r raised to power minus 1. So arranging it, we get, and taking k is equal to 1. So m is equal to mv square by r. This is the formula that we have to derive by the means of dimensional analysis. So I think you all might have understood this question. So we are going to understand this question once more. Derive the formula F is equal to mv square by 4 by r. This is the centripetal expression by the means of dimensional analysis. So our equation becomes F is the force. So F is directly proportional to m raised to power a, v is the velocity raised to power b, r is the radius, that is raised to power c. This is our first equation. Writing the dimensions of all the quantities on both sides. So for force it becomes mlt raised to power minus 2 is equal to, taking constant k, m raised to power a, and velocity is lt raised to power minus 1 whole raised to power b, L raised to power c, that is the length, radius is the length. Comparing the powers of m, L, t on both sides. For m, it will be 1 is equal to a, so the value of the constant a becomes 1. 1 for L, 1 is equal to b plus c. This is our second equation. For t, it will be minus 2 is equal to minus b. Minus minus gets cancelled, so b is equal to 2. Value of b becomes 2. Substituting the value of b in the second equation. So 1 is equal to 2 plus c. So c is equal to 1 minus 2. So it becomes minus 1. Substituting all the values of the constants a, b, c in the first equation. So it becomes f is equal to, taking the constant k is equal to 1. So it becomes f is equal to m raised to power 1, v raised to power 2. So it becomes v square, and r raised to power minus 1. Arranging it, we get F is equal to mv square by r. This is the formula that we have to derive. So I think you all might have understood this question. So now we are proceeding to another question. So here V is equal to A plus B into T. We have to find the dimensions of A and B, constants A and B in this equation. So the dimensions of all the terms will be equal. So the dimension of V is equal to dimension of A. Here V is the velocity. That becomes Lt raised to power minus 1. So this is the dimension for A. Similarly, V is equal to Bt. So that writing the dimensions for velocity, mlt raised to power minus 1 is equal to B. For time it will be t raised to power 1. So it will become lt raised to power minus 1 upon t raised to power 1 is equal to B. Solving it becomes lt raised to power minus 2. So this will be the dimension for B. So B will be the acceleration here. This is the quantity that is, and that it will be going to represent, and A will represent the velocity, which will be the initial velocity. So this is the first equation of motion, that is V is equal to U plus AT. So I think you all might have understood this question. So we are going to understand this question once more. V is equal to A plus Bt. This is the equation that is given, where V is the velocity, T is the time, T is the time. So we have to find by means of dimensions the dimensions of A and B. So the dimensions of all the terms is equal. So the dimension of velocity becomes equal to dimension of A. So the dimension of velocity is Lt raised to power minus 1. So the dimension of A becomes Lt raised to power minus 1. Similarly, dimension of V becomes equal to the term Bt, where T is time. So the dimension for velocity is Lt raised to power minus 1 is equal to B. This is the constant, and the dimension for time is T raised to power 1. So it will come in the denominator. So B becomes Lt raised to power minus 1 upon T raised to power 1. So B is equal to Lt raised to power minus 2. This is the acceleration. So I think you all might have understood this question. So we are proceeding to our next question. So the next question is, S is equal to ut, so it will become at plus half bt square. This is another equation that is given, and we have to find the dimensions of A and B. So here again the dimensions of all the terms will be equal. So the dimension of S becomes equal to at, where S is the distance, so its dimension becomes length. L is equal to A, and it will become T's time, so it is T. So it becomes L upon T is equal to A. So it becomes A is equal to L T raised to power minus 1. So this is our dimension for A. Now similarly we have to find the dimension for B. The constant term doesn't have any dimension, so we will not take half. So it becomes dimension of S is equal to bt square, the square of time. So the dimension for S, that will represent distance, that is L. B and T square will be T square. So the dimension for B is equal to L upon T square. So it becomes B is equal to LT raised to power minus 2. This is the dimension for the constant B, that is Lt raised to power minus 2. That is, it is going to represent acceleration A. That is the physical quantity that it is going to represent. The dimension for A is lt raised to power minus 1, so it represents the velocity, so it represents the initial velocity u. So this is our second equation of motion. So it is s is equal to ut plus half at square. This is the answer. I think you all might have understood this question. We are going to understand this question once more. So we are given an equation s is equal to at plus half bt square, and by the means of dimensions we have to find the dimensions for a and b. So the dimension of s becomes equal to dimension of at, where s is the distance and t is time. So the dimension for distance is L and for time is t. So it becomes L upon t is equal to A. So it becomes Lt raised to power minus 1. So it is going to represent velocity. So it will be the initial velocity u. Similarly, s is equal to bt square, where t square is the square of time. So it becomes L is equal to bt square. So b becomes L upon t square. Simplifying, we get L t raised to power minus 2, and it is going to represent the dimensions of acceleration. So it will be going to represent the physical quantity acceleration, that is A. So our equation becomes s is equal to ut plus half at square. So I think you all might have understood this question. So please watch this video till end, subscribe me and press the bell icon. Thank you.